So in this video, we're going to talk about how to write equations of lines in point-slope form. So remember I told you that there are three forms of linear equations. We talked about slope-intercept form. Today we're going to talk about point-slope form, and we also talked about standard form in the last unit. So depending on the type of information that you're given, it will make more sense to use a specific form to write the equation of a line. So today we're talking about point-slope form. So this is point-slope form. It's y minus y1 equals m times x minus x1. The value of m tells you the value of the slope, and x1, y1 are the coordinates of a point that's on the line. So when you're given a slope and given a point, it's best to write the equation in point-slope form. So let's look at these three equations, and let's identify the slope and a point on the line based on the equation that's given. So remember, we're always going to compare to point-slope form. So we're going to compare to y minus y1 equals m times x minus x1. So in this first equation, we can see that we have the coordinates of the point, 3, 4. So the point that is on this line will be 3, 4. And the value of the slope will be the value of m. So the slope will be m equals 5. So let's look at this second equation. Let's compare to y minus y1 equals m times x minus x1. Well, the difference between this equation and point-slope form is that in point-slope form, we have subtraction signs. So we're going to go backwards, and we're going to turn these addition signs into subtraction signs. So we have y minus negative 2 equals negative 4 times x minus negative 1. So that means that this is the value of y1, this is the value of m, and this is the value of x1. So that tells us that we have the point, negative 1, negative 2, and we have our slope, which is m equals negative 4. So now let's look at this third equation. We want to compare to y minus y1 equals m times x minus x1. Well, when we compare, we have a little bit of a difference here. We have a y, but nothing is being subtracted from it. Well, remember, if nothing is being subtracted, we can say y minus 0, and that equals 1/3 times x minus 7. So that means that my point is going to be x1, y1, which is 7, 0, and then the slope is going to be m equals 1/3. So now let's find the equation of a line with slope m equals 3 that passes through the point 1, negative 2. So when we have 1, negative 2, that tells me a value of x1 and y1. We have m equals 3, so let's plug into y minus y1 equals m times x minus x1. So when we do that, we get y minus negative 2 equals 3 times x minus 1. Y minus negative 2 is going to become y plus 2, because minus and negative is positive. So we have y plus 2 equals 3 times x minus 1. So that is the equation in point-slope form. Let's write the equation of a line with slope m equals negative 1/3 that has the point 6, negative 4. So we have our slope, we have this point, which is x1, y1. Let's plug into y minus y1 equals m times x minus x1. So when we plug in, we get y minus negative 4 equals negative 1/3 times x minus 6. So when we plug in y minus negative 4, that becomes plus. So we have y plus 4 equals negative 1/3 times x minus 6. So that is the equation of the line in point-slope form. Let's find the equation of a line with slope m equals 3 that has the point negative 4, negative 7. So the slope is 3, the point is x1, y1. So when we plug in, we get y minus y1 equals m times x minus x1. So we get y minus negative 7 equals 3 times x minus negative 4. So let's fix these minus negatives. They're both going to turn into a plus. So we have y plus 7 equals 3 times x plus 4. So now let's graph the line described by the equation y minus 3 equals 2 times x minus 1. So we want to always compare to point-slope form. So let's write this out. And we are comparing to y minus y1 equals m times x minus x1. So that means that the point that we have is going to be 1, 3. So that is the point. And then the slope is going to be 2. So let's first start off by plotting the point on the graph. So we're going to plot 1, 3, which is right here. And then we're going to count slope from this point to plot the second point. Well, our slope equals 2. Remember, that is 2 over 1, so we can say that we go up 2 and then right 1 to plot the second point on our graph. So we're going to go up 2 and then right 1, and then connect the points to form the graph of the line. Now let's graph the line described by y plus 1 equals negative 2 times x plus 3. So we have y plus 1 equals negative 2 times x plus 3. So this is going to compare to y minus y1 equals m times x minus x1. Well, let's go ahead and let's turn those addition signs into subtractions. So we have y minus negative 1 equals negative 2 times x minus negative 3. So that means that my point, my x1, y1, is going to be negative 3, negative 1, and my slope equals negative 2. So I go to negative 3, negative 1, and put my first point there. My slope is negative 2, so that's negative 2 over 1, which means I go down 2 and then right 1. So from this point, I'm going to go down 1, 2, and then right 1, and then connect the points to form the graph of my line. So now let's graph the line described by the equation y equals 1/2 times x minus 5. So we have y equals 1/2 times x minus 5. If we compare to point slope form, we have y minus y1 equals m times x minus x1. So we have y, and nothing is being subtracted from y, so that is basically y minus 0 equals 1/2 times x minus 5. So that means my x1, y1 is going to be at 5, 0, and my m is going to be equal to 1/2. So I go to 5, 0, put my first point there. Then I'm going to count slope 1 over 2, which is up 1, right 2. So I go up 1, right 2, and that is my next point, and then I can connect these points to form the graph of a line. So now let's write the equation of the line given the graph, and let's write the equations in point slope form. Well, to write in point slope form, I need to figure out the point and I need to figure out a slope. When you're picking a point, you can just pick any point that's on your graph. So for example, here, I'm going to pick the point 3, 5. So 3, 5 gives me an x1 and a y1 that I can use in my equation. Now I need to figure out the value of the slope. So to figure out slope, I'm going to pick another point, and then I'm going to draw a path going from left to right. So I go right 1, and then I go up 2. So my slope, which is rise over run, is going to equal 2 over 1, which equals 2. So if I plug into my equation, I get y minus y1, which is 5, equals 2 times x minus x1, which is 3. So that is the equation now written in point slope form. So now let's write the equation of the line shown in point slope form. So once again, I'm going to pick a point and figure out the slope. So the point that I have is, let's see, you can pick any point you want. I'm going to pick this point 4, negative 3. And then I'm going to use that to figure out the slope. So the slope, if I pick another point, this point looks good. Let's go from left to right. So I go down 1 and I go right 2. So my slope equals negative 1 over 2. So if I plug into point slope form, I get y minus y1, which is negative 3, equals negative 1/2 times x minus 4. So y minus negative 3 is going to turn into plus. So I have y plus 3 equals negative 1/2 times x minus 4. So remember that there are 3 forms of linear equations: slope-intercept form, point-slope form, and standard form. They're useful depending on what kind of information you have. If you have the slope and the y-intercept, you can use slope-intercept form, which is helpful when graphing. If you have the slope and a point, you can use point-slope form, which is also helpful when graphing. Standard form is the one that's not super helpful when you're graphing. You can use it to calculate the intercepts, or you can change standard form into slope-intercept form whenever you want to graph. So in summary, remember that given a point x1, y1, and a slope m, you can write the equation of the line in point slope form, which is y minus y1 equals m times x minus x1.